This is called a paired sample t-test or a dependent samples t-test. What's the difference between paired sample and an independent sample? Well, if we read the problem, you can see that we have 9 students taking the SAT. Later on, these same students took a preparation course and retook the SAT, and they got a new set of scores. What we're interested in is, has the test preparation increased their scores? Has it had any effect on their scores? So everything is the same except for the test, the test assisting them to be better prepared. And we talked in terms of controlling for everything else. Another thing that's a feature here is that it's assumed that the standard deviation of the 2 distributions is the same, and therefore that the standard deviation of the set of differences is the same as normal. So you can see what we're looking at here. This is usually a calculation that you have to do when you start one of these. We calculate the difference between the before and the after. We can see here that in this particular calculation, a positive difference indicates an improvement in the score. Obviously, a 0 indicates no change, and a negative indicates that the student did less well on the second round as he or she did on the first. The relevant statistics are the average of the differences. That's what D bar is in this notation, and the standard deviation of the same set of differences. That's S sub D. This is essentially a one sample t-test. The only thing is we're using these numbers here. So let me move this stuff around a little bit so we can work towards the bottom of the thing. Null hypothesis. Well, in the problem, if you look back, you'll see that what it says is that the claim is that the test preparation had no effect on their scores. Now, that would be that there was no difference between before and after. And the notation that's used in your book and most everywhere else is the following. For the null hypothesis, we write mu sub d is equal to 0. That is to say that even though we have a difference here, we're testing it against 0 change. And our alternate hypothesis, we are at liberty to use a one-tail or a two-tail test. Let's use a two-tail test just for fun. We'll say mu d is not equal to 0. Two-tail test. Okay. The test statistic is just a t with some different notation. What we have is we have t is equal to d bar minus mu d divided by sd over the square root of n. Now take a close look at that. That is nothing more than a t-test, a one-sample t-test with just different. Instead of having x bar, we got d bar. Instead of having mu, we got mu d. Instead of having s, we've got s sub d. Okay. The numbers. D bar is 15.6 minus 0. That's the hypothesis. 19.4 divided by the square root of 9. Okay? And so we do our calculation. Let me see what a handy way to put this is here. This might work. Let's see here. Okay, we've got 15.6. 15.6 divided by, paren, 19.4 divided by the square root of 9, which I'm sure you all know is 3. So we get that. And our answer is 2.41. So t is equal to 2.41. Critical values. Well, let's get our t-table. We have n minus 1 degrees of freedom. So we're talking about 8 degrees of freedom, 0.52 tails. Okay, here's 0.52 tails. Here's 8 degrees of freedom, 2306. So here's 2306, 2306. Here's the rejection region, and here's 2.41. So we just barely reject the null hypothesis. That's what it says. Okay. Interpret results in terms of the original claim. Okay, let's take a look. Claim is H naught, and we rejected H naught. Therefore, there is enough evidence to reject the claim that test preparation had no effect. There is enough evidence to reject the claim that the test prep had no effect. Always have a problem with double negative. Well, there's no double negative in there. Isn't that nice? That's a good English sentence. Okay, p-value. Now we're going to see how close we come to 0.05. Our test statistic is 2.41. Okay, we look at the 8 degrees of freedom line, 2.41, and we can see that 2.41 falls between 2.306 and 2.896. Therefore, we are between 0.02 and 0.05. That is to say, we did reject, but just barely. 0.02 less than p less than 0.05. And as always, the proof of the pudding is in the calculator verification. So let's do the calculator. Okay. As I told you, this is just a one sample t-test. Stat tests 2. One sample t-test. Okay, mu naught, let me find a good place to put this so you can see it well, reasonably well. Okay, mu naught is 0. That's mu sub d. X bar is 15.6. It's already in there, X 15.6. The standard deviation is 19.4. The sample size is 9. And we did, in this case, we did a two-tailed test. So let's move down here and let's select a two-tailed test. Calculate. T, 2.41. Well, that's pretty much what we got, isn't it? P-value, 0.042. We said it's between 0.02 and 0.05. It's a little less than 0.05. So the results here are consistent with the results that we got by hand, which says that we're pretty sure that we've done this problem correctly.